Yeah, good afternoon, everyone. It's still your online tutor and friend, Aloko Abraham Ayonemofe. Um, I would like to take the subject chemistry before we know because we know that JAMB is fast approaching, and we have to take important topics so that we will not lag behind. Um, the topic I would like to treat under chemistry is the topic we all know as kinetic theory of gases, where we have various type of what laws that guides the what gas as a topic. And this topic I would like to take is a very important topic to the JAM body because they can't do without setting it in their what JAM question. Now we have Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, Graham's law of diffusion, ideal gas equation, general gas equation, a lot of them. So I will take them one after the other. I will start with Boyle's law. Boyle's law states that the volume of a given mass of gas is inversely proportional to its what? Pressure at constant temperature. Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure at constant temperature. That is the definition of Boyle's law. And the formula for Boyle's law is known as P1V1 is equals to P2V2. P1 stands for initial pressure, P2 stands for final pressure, V1 stands for initial volume, V2 stands for final volume. Then to the next law, I will go to Charles' law. Charles' law states that the volume of a given mass of gas is directly proportional to its temperature at constant pressure. Then the formula for Charles' law is known as V1 over T1 is equals to V2 over T2. And now the way I arrive at that, we know that V1 is initial volume, T1 is initial temperature, V2 is final volume, T2 is what? Final temperature. And so to say, we have some terms, we have some constants that we use generally under calculation of what? Laws. So I will list them after the definition of the what? Laws. The next law I would like to talk about is the what? Ideal gas equation. Ideal gas law. The ideal gas law, it does not have a particular state, but it can be written as PV is equals to nRT. PV is equals to nRT. P stands for pressure, N stands for number of mole, V stands for volume, R stands for what? Constant, and T stands for what? Temperature. Then the last one I would like to talk about is Avogadro's law. Avogadro's law is a very simple law to master and understand. Avogadro's law states that equal volume of all gases at the same temperature and pressure contains the same number of molecules. That is the simple definition of Avogadro's law. Then the next law I would like to talk about is the Gay-Lussac's law. Gay-Lussac's law states that when gases combine, they do so in volume which are in simple ratio to one another and with the volume of the gaseous product. That is the definition of Gay-Lussac's law. Then the next one I would like to talk about is the what? Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the what? Vapor density or relative molecular mass. How do we get relative molecular mass? This is gotten by what? Multiplying 2 by the vapor density. That is the definition of Graham's law of diffusion. And we have some things to see, to look at. The first thing is, under Graham's law of diffusion, the first thing we need to note is that we deal with rates, we deal with time, and we deal with volume. Rate, time, and volume. If we are calculating rate under what? If a question states rate in the question, that means it will be what? R1 over R2 is equals to square root of what? Relative molecular mass 2 over relative molecular mass 1 of the various gases that is given. Then we are dealing with time. It will be T1 over T2 is equals to square root of what? Relative molecular mass 1 over relative molecular mass 2. If we are dealing with rate, the what? Relative molecular mass of the second gas will be the first one on top and the first one will go down. But if we are dealing with temperature, one will remain on top, two will go under. So that is all I have to say under the gases. But we have some terms that we need to know about. The first one is temperature. The general constant for temperature is 273 degrees Celsius. 273 degrees Celsius. That is the constant for temperature. Then for pressure, we have 1 atm, 760 millimeter mercury, and we also have 1.01 times 10 raised to power 5 Newton per meter square. Those are the constants for pressure. And for R, which is the what? Constant for what? Right, under what? Ideal gas equation, it is known as 0.082 atm dmq per Kelvin per mole. That is the what value for R under the what ideal gas equation. So those are the constants that we have. So thank you very much for staying tuned to this channel and watching this video. Please like, subscribe and share this video. Thank you very much. And in my next class, I will come to solve questions pertaining to this topic. Thanks.